This video is brought to you by our own Meta. Thank you so much for donating. If you want to support Brackeys yourself, you can go to patreon.com/Brackeys.
Thanks for tuning in at Brackeys.
Hello everyone and welcome to this video on creating a tower defense game in Unity. Today we'll be finishing off our laser beamer by actually making it damage and slow our opponents. In the process, we'll also clean up our code a bit, separating out some of the enemy movement from some of the stats and dying and that kind of stuff. So yeah, a much needed video, and let's just dig right into it. So as you can see, I'm here in Unity, and what I want to begin with is just remove this laser beamer from our scene, and then we'll only spawn it through our shop, because there's really no reason for it to sit there. Cool, and then what we'll do is we'll find the prefab down here, and we'll have a look at how it's composed. So we have the turret here, and this is where we handle all of our shooting. So let's double click that to open it up. And basically what we want to do is just add another variable onto the part that is exclusive to our laser here. So under the header, use laser, this is where we'll go ahead and make a new float, and we're going to make it a public float. And actually, let's make it an integer. I don't think we need that much control. And let's make this our damage over time. And whatever this is set to is the amount of damage that the enemy will receive each second it's hit by our laser. So by default, let's just set it to something like 30. And that means that each second our laser will be damaged by 30 hit points. Or our laser will damage our enemy by 30 hit points. Great. And then we can go down here, and inside of our update loop, you can see we call laser each frame. And then we can go down here to where we do all of that stuff, lasering. And we could either add it to the top or to the bottom. This is all of the graphic stuff. And then down here we could damage. Actually, I think I'm going to do this before all of the graphic stuff, because it is the most important part is actually damaging the enemy. So what we could do here is just simply go target. And our target has a component called enemy. So we could go get component of type enemy. And then we could do dot take damage. And we could input some amount. In our case, we want to input our damage over time and then multiply that by time.delta time in order to cancel out any differences that might be between one computer's frame rate and another computer's frame rate. And this will also make sure that this is per second and not per frame. So cool. So this should actually work. However, our take damage method currently is only used to receiving an integer. And because we are damaging the enemy a tiny bit each frame, we can't really deal in integers. We might damage him by 0.05 one frame or whatever, depending on the damage over time and depending on the frame rate. So let's go in and just modify our take damage. And this is super easy. We just need to find our enemy script, double click it. And instead of having a public integer health here, we'll make that into a float, gives us more control. And then down here we can make this into a float as well, so we'll take the amount as a float. And that's all we need to do, and we should actually see this working now. So if we go in here, hit play, and scroll over and spawn one of these guys in, you can see that if we I'm gonna pause the game here and select our enemy, and you can see he's currently on 14 health here, and if we just keep going, you can see it quickly decreases and then he dies. So that is indeed already working. However, there are a few issues with this. The first one is that currently we are getting the component of our target every single frame, and that's a super taxing operation, especially if you have a really complex object. So what we're going to do instead is cache this into a variable. Much like we have a variable up here containing our target, we'll create another one which is going to be of type enemy, containing our target enemy, or just call it enemy, the enemy component of our target. And we're not going to default that to anything, but we are going to set this instead inside of this if statement here. So where we update our target, search for the nearest enemy, we get the nearest enemy, and we set target equal to the nearest enemy dot transform. And what we then do is simply say that we want our target enemy to be equal to the nearest enemy dot get component of type enemy. So basically the same thing that we did down here, but we're just making sure that we only do this when we actually update our target, and that is a lot less than every frame. Cool. So then we can just replace this piece of code here with our target enemy, and things should still work just fine. So the next thing that we want to do is add some slowing to our enemy. And before we actually do that, I want to separate out some of the code, because if we currently have a look at our enemy script, I find it's a bit more complicated than it necessarily need to be, because we have speed variable, we have a health variable, then we have some value, which is the enemy's worth, and I am actually going to go in here and replace that with worth. And in order to rename something and substitute the name all other places as well, you can just do Control-RR in Visual Studio. And you could also go right click, and I believe it's called rename here. In some programs it's called refactor. Or you could of course just write a new thing and then place it all the other places that it appears. So now it's called worth there. And then we have a death effect, and that these things all make sense. This is stuff central to the enemy. It's things that describe the enemy: speed, health, worth, and how it looks when it dies. And then we get to the target and the waypoint index. And this is something that's very specific to movement. So what I want to do is take stuff like this and move it into a separate script, just to kind of make our whole code easier to read and more modular. So we'll go inside and find our enemy prefab here. And let's create a new component called, well, enemy movement. And let's make this a new script and create an add. And let's double click that to open it up in Visual Studio as well. And reload all there. And let's just remove all of the default stuff in here. And let's paste some stuff from here. So let's select the start method and these two variables, because that's all movement code. Let's hit Control-X to cut it out. And then let's paste it inside of our enemy movement. And we have more to go. Then the take damage method, again, specific to describing the enemy and changing the health around. The same thing with dying. And then we have our update, and everything we do inside of the update is movement related. We get a direction, we translate it, we also find the distance to the next point and stuff like that, and getting the next waypoint and ending the path. All of this is specific to movement. So let's take all of this code as well and simply cut that out, Control-X or Command-X if you're on the Mac, and let's then copy that in here instead. And this should work right off the bat, except for one thing, and that is our speed variable. Because that speed right here that we're using to determine, well, how far we want to move each frame, that actually sits still inside of our enemy. And we could, of course, go ahead and move our speed inside of our enemy movement, but then we wouldn't have a central place for all of the stuff that we want to change about our enemy. And I think it's a good to have a place. You could call it enemy stats or just enemy, with all of the characteristics of your enemy, and then have other components connect to that enemy in order to get information about speed and health and stuff like that. So let's just sync up our enemy movement to the enemy script. So in order to do this, we'll first require it as a component. So we'll say our enemy movement won't work unless we have a component of type enemy that sits on the object. That will just ensure that. And then we'll also make a reference to this, a private variable called enemy. And we'll just call this one enemy with a non-capital E there. And in the start method, we'll set enemy equal to get component of type enemy. So now we find the enemy on our object and we call it enemy, and then we can simply, instead of going speed, we can go enemy.speed, and it's actually that easy to do. Awesome. So I believe that's all we needed to do here. So the next thing that we could do, and let's just test out if this is working here. So you can see we have enemy movement, but it has no attributes. We have all of our attributes in here. And they should link up nicely so that when we now hit play and wait for an enemy to spawn, it works just as before. And what this allows us to do now is, if we go inside of our turret, we have our target enemy, and we can go in here and add a new function. Say we want to go target enemy.slow, and then we want to give it some slow factor, say 0.5, meaning that we will cut the speed in half. We could also do 0.3, meaning that it should only have 30% speed, or you could turn it around and say that at 30% slow, which means it will have 70% speed. You can do whatever you want there. let's actually do some kind of percentage. So the number that we input will be the amount that we want to slow. So in order to do this, let's make this into a variable first of all. So let's make a public float here, and this is going to be our slow percent or percentage, and we're going to set that equal to something like maybe 0.5 is going to be just fine for now. It might be quite a heavy slow, but we're not going to have it so that turrets, if you have multiple turrets on one target, that it will stack. We're just going to set this as a limit. So even though you have 2 turrets on the same target, it's still just going to be half the normal speed. So let's do that, and let's go down here, and let's just call the function right away, and then we'll go in and create that. So we'll have some method called slow, and we'll put inside of that our slow percentage, or actually I'm going to do slow amount. And that is going to be a value between 0 and 1. 0 between, meaning that we won't slow at all, and 1 meaning that we will completely remove the speed. So we'll just make the enemy stop. So yeah, and then we'll add this function in here, and we can use pretty much this way of writing the method as inspiration. So this is also going to be public because we will call it outside the class. It's going to be a void because we don't want to return anything. It's going to be called slow, and it's going to take in some kind of amount or percentage or whatever you want to call it. I'm just going to call this one percentage. And percentage is a bit misleading because it's a value between 0 and 1 and not in the hundreds. But that's all right. We don't need to get too technical with this. And then we can say here we simply want to set speed equal to, and now comes the problem, because what do we really want to write here? Do we want to say that we want to multiply speed by the 1 minus the percentage here? So this would mean that our new speed would be equal to our old speed, and then multiplied with, and we would have to do this, multiplied with 1 minus our percentage. So in case we want to slow by 30%, we would write 0.3. And that means that we want our speed to be 70% of the original speed. So 1 minus 0.3 is equal to 0.7, and speed times 0.7 would be 70% of our speed. So that this makes sense. However, if we do this every frame, our speed will keep decreasing, because we'll do that every frame. We'll reduce by 30% every single frame, and then eventually we are going to gradually go towards 0. It's never going to reach 0, but it's going to get really close and slow up really quickly. So instead we want this idea of a start speed, some base speed that we work off and use as a baseline. So this speed here, we're actually going to keep that, and then we're also going to have a public float, which is going to be our start speed. And we're going to set this equal to 10 by default as well. And we can now remove this here, because we don't want our speed to be equal to anything. We want that to start off at the start speed and then be modified as we go. And then we can go in here and create a void start. And inside of this start method is where we want to set speed equal to start speed. So when we start the game, our speed variable becomes start speed. And then down here we want to set speed equal to start speed. And because start speed is never modified, we can do this every frame, no problem. So there we go. So that should actually modify our speed. However, a few problems again will arise. So if we have a look inside of Unity here, you can see now that our enemy has a start speed, but the speed still shows up. And that's annoying because we don't want to be able to modify this. It's not going to have any effect. You can see as soon as I start the game here and then find an enemy that is actually spawned in, here we go. So we'll select this enemy here. You can see that the speed is just set to the same as the start speed. It doesn't matter. So what we'll do about this is we'll simply remove this speed here from the inspector. We still want it to be public because we want it to be accessible from within our enemy movement, but we don't want it to show up. So we use a tag here called hide in inspector. And writing this right before any variable simply means that it will not show up. So it says here makes a variable not show up in the inspector, but be serialized. So there we go. Cool. So that is all the functionality we're going to need here. And you will notice that if we go in here now and create one of these and make him shoot, you can see that it actually slows the opponent. However, if we were to put him a bit further away here, maybe here, it slows. And you will see that when he gets out of range, he's still slowed. So we need some way of canceling this back out. And the way that we are going to do this is we're going to utilize how Unity calls update loops. Because currently, our turret here is calling the laser function inside of the update loop. And the laser function then slows the target enemy. And we go in here, and that changes our speed. Then in our enemy movement, the update loop is called, and that means that we will use that speed to actually move. What we could then do is just in here, change the speed variable back. So we could say enemy.speed equals enemy.startSpeed. There we go. So we've now reset our speed. And that's going to be fine because it means that if our turret is no longer slowing us, we've just reset our variable. But if it's still slowing us, well, then it's just going to call this again and slow it again. It's going to go in and change the speed. And then it's going to use the speed to move and then reset it again. So we have this loop here where one update changes the speed, one update uses it and then resets it. And unless the other one is called again, fine, it's just reset. And if it does, well, then we just go in a cycle. And that's because the way that Unity handles these update functions is that it calls all of the awake functions, then it calls all of the start functions, and there's a whole hierarchy to this, and all of the update functions are called not at the same time, but just after one another. And you might say, well, what happens then if our enemy movement is called before our enemy thing here? But, well, that isn't actually necessarily a problem, because that just means that we will call this code and enemy speed will be the normal speed, and then it's going to reset it. And then the other thing here is going to be called, so the next time that this is called, the speed will have changed. So that will just offset by a single frame, which is definitely non-noticeable. But if we wanted to get rid of that, I will show you how you can do that in just a second. But for now, let me just demonstrate that this should in fact be working. So if we now go in here and place a guy, and that is not going to work because he's going to kill the enemy before we can do anything about it. So let's just place one here. You can see it slows the enemy and then he speeds right up again. So it already works just the way we want it to. And this is going to work with all of the different turrets, no matter how many turrets we have. So we could go ahead here and place multiple of these in there. And let's just do that by allowing ourselves to start with a bit more money. So let's just start with a lot of money here, hit play, and we can go in here and we can put some of these guys down, and you can see right now they will damage the enemies a lot, but as the amount of enemies spawn increases, you will see how they easily just switch between targets. Here you can see that's the first one, then it slows the second one, and this should just be working. So what we can then do is maybe a better practice than just having the movement be offset by a single frame would be to go in and ensure in some way that the enemy script here is called before the enemy movement. And a way we can do this, and of course Unity supports this, is we go under Edit and then Project Settings and go under what is called the Script Execution Order. And normally I tell beginners not to mess around with this because normally you can get around this by writing different code, and in this case you could do that as well. You could have some kind of, for example, a list of all of the different debuffs that you want to put on your turret, and then or on your enemy, and turrets can then register a debuff and then unregister it when it stops shooting, and then the enemy will just be responsible for going through all of the debuffs and adding them on each frame. And that's maybe a more solid way to do it, but I think it's definitely overkill for what we're doing because we only want one type of debuff. But what you can do here is you can go ahead and add a new script. So we're going to add our enemy movement, and iCloud still demands of me to purchase something. And you can see here, it adds scripts to the custom order and drag them to reorder. So in our case here, the default time is when all of the different scripts will be executed. And we can go ahead and put a small delay on our enemy movement. And that means that all of our scripts will execute along with the enemy script that changes and our turret script that changes our speed. And then when they're done, exactly 100 milliseconds after, we are going to execute the enemy movement. So this just allows us to put an order. If we wanted this to execute before, we could simply drag it up there and it's now executed negative 100. So that means 100 milliseconds before the default time. And we could actually go in here and be explicit about it as well. So we could go in here and put our enemy before there and do that. But I think this is going to work just fine. So if you hit apply on that, you won't see any real noticeable difference. But the scripts are now executing in the proper manner here. So you can just see that working there. Awesome. So I'm actually really happy with what we've done with the lasers here, and they are just so much fun to play around with. And this was pretty much all I wanted to show for this video. If you have suggestions as to what you want to see next, definitely leave them in a comment. I want to do something about ending the game. We also have to look at game ballots at some point, and I also kind of want to expand on the different types of enemies that we're able to spawn and how they increase in difficulty as the game goes on. So thanks for watching. That was all for this video, and I will see you in the next one. Thank you so much to all of the awesome people who donated in September, and a special thanks to Aaron Meta, Robert Roche, James Calhoun, Kim Rose Gugos, Bao Andan Duang, and Vixen P. Thank you so much for donating. You guys are awesome. If you want to support Brackeys yourself, you can go to patreon.com/Brackeys.